Okay, now we're going to talk about concavity, and I don't mean the ones in your teeth either. Sorry, jokes really don't get any better. Year just goes downhill from here. Okay, write down in your notebook the definition of concavity. Let f be a differentiable function on an open interval I. The graph is concave upward if f prime is increasing. So if the first derivative is increasing, then it's concave upward. If the first derivative is decreasing, then it's concave downward. Now, the test for concavity is really pretty straightforward. Let f be a function whose second derivative exists. If the second derivative is positive, then it's concave up. If the second derivative is negative, then it's concave down. Would you like a little hint when you're looking at a graph to determine whether it's concave up or concave down? Okay, if you look at the function and it makes a smile, it's concave up. If you look at the function and it makes a frown, it's concave down. All right, let's try a problem. Sketch and determine the open intervals where f is concave up or concave down. Now the first thing I'm going to do is rewrite this function as 6 times x squared plus 3 to the negative 1. And I'm going to do that because I'm going to have to take a couple derivatives. And I'd rather not use the quotient rule if I don't have to. So f prime is equal to 6 times negative 1 x squared plus 3 times x to the negative 2. All right, let me rewrite this as, times 2x. Forgot that. Got to make sure you do the derivative of the inside. So this is negative 12x divided by x squared plus 3 squared. That's the first derivative, and that's all I really need it for. So now I'm going to come through and do the second derivative. The second derivative is equal to, now I have a quotient rule. So it's the denominator, which is x squared plus 3, quantity squared times the derivative of the numerator, which is negative 12, minus the numerator, which is negative 12x. Don't forget all those negative signs, times the derivative of the denominator, which is 2 x squared plus 3 times the derivative of the inside there, which is 2x, all, divided by, I lost my pen there, x squared plus 3, quantity squared. So 2 squared is 4. All right, let me rewrite this. If you, I don't have a lot of room to do the algebra, you can do it. Let me just go on and show you the solution. You can do algebra. It's 36x squared divided by x squared plus 3 cubed. All right, now the denominator is always positive, so we don't have anywhere where the second derivative is undefined. Now, where is f double prime 0? Okay, where is the second derivative? All right, well, it's 0 at x equal plus or minus 1. So we're going to, and that kind of makes sense. Oh, 1. Sorry about that. 1. And that kind of makes sense if you look at the graph. All right, let me erase that. Okay. So we have our 3 regions from negative infinity to negative 1, from negative 1 to 1, and from 1 to infinity. All right? So negative infinity and then from 1. Now, you can pick any points you want. I always pick x equals 0 if I can because it makes your life easy. And then I try to make things as symmetrical as possible. All right, so now I want the sign of f, not prime, but double prime here. All right, what's the sign of the second derivative? Well, let's see. Let's pick negative 2 because it's a nice convenient point. I'm going to switch colors here for this. F double prime at -2 is 36 times -2 squared, so that's going to be positive. The numerator is going to be positive, and the denominator is, of course, going to be positive. So it's positive. All right, so F double prime is positive, so this is concave up. Let's look at x equals 2. Why? Because I'm going to have basically the same answer. This is going to be 36. 2 squared minus 1 is positive. X squared plus 3 cubed. All right, and this is also positive. So this is concave up because F double prime is positive. Now let's look at this one right here. Let's look at F double prime of 0. That'll be 36 times 0 squared minus 1 divided by 0 plus 3 cubed. All right, and this is going to be, let's see, negative. All right, so here F double prime is negative, so this is concave down. Now, your turn. See if you can do this one. Stop the tape, and when you're done, turn the tape back on because we have another problem to work through. Let's look at this problem right here. Now, this problem is interesting because there are points in the graph itself which are not defined. At x is plus 2 and -2, you wind up with a 0 in the denominator. So let's start by taking the first and second derivative. All right, so F prime. All right, in this case is x squared minus 4 times the derivative of the numerator, which is just 2x, minus numerator x squared plus 1 times the derivative of the denominator, which is 2x, divided by the denominator squared, x squared minus 4 squared. Now if I simplify this, you're going to see the 2x's actually wind up canceling. So this becomes negative 10x divided by x squared minus 4 squared. All right. So let's look at the second derivative, and I'm going to switch pen colors here. Come on, pen color don't want to switch. All right. Second derivative is equal to, and again we have a quotient rule. So this is x squared minus 4 squared times the derivative of the numerator, which is negative 10, minus negative 10x times the derivative of the denominator, which is what, 2 times x squared minus 4 to the first power times the derivative of what's inside, so that's 2x, all divided by my denominator squared, which is x squared minus 4. Okay? To the fourth. Now, when I simplify this, I'm going to be able to factor out an x squared minus 4. I don't have a lot of room, so I'm not going to try and do it here. This becomes 10, 3x squared plus 4 divided by x squared minus 4, and this is going to be cubed. Now, the numerator is always positive, and the denominator can be negative, it can be positive. So when we look for sign, all I'm really going to worry about is the denominator. Now, let's look at the intervals we need let's figure out what intervals we need to deal with. This function is never 0, all right? However, you do have f double prime is undefined at x equals 2, x equal plus or minus 2. So let's break it up into those intervals. Interval from minus infinity to -2, from -2 to 2, and from 2 on to infinity. You can pick any test value you want. Let's do 3, -3, and I always love 0. What's the sign of f double prime? Well, at -3, of -3 and +3, you're going to wind up with the exact same value. And I'm out of room, which is why I'm doing this. So this is 10 times 3 times 3 squared. It's a plus or minus, it doesn't matter. Plus 4, so that's going to be positive, divided by plus or minus 3 squared minus 4, so that's 9 cubed. 9 minus 4 is positive 5, so this is going to be positive. All right, so f, the second derivative of -3 is positive, just as the second derivative of +3 is positive. So these are both concave up. What about between -2 and 0? Well, the second derivative of 0 is 10 times 4 times -4 cubed. And this is negative. So this is concave down. And D-O-W-N. Now you can see here, this is making a smile, this is making a smile, and this is making a frown. Concave up, concave down, concave up. And that's what we were shown mathematically. Your turn. Give it a try, do your best, and when you're done, turn off the video and finish your homework.